Welcome, boys and girls. My name is Mrs. Cheryl Bradshaw, and today we will be looking at volume and its relationship with capacity. On the table in front of me, I have some items. These objects are going to assist us as we revise capacity. Right in front of me, I have a mug filled with red liquid. This mug is a 1 liter mug. It measures up to 1 liter. On my right, I have a 500 milliliter bottle of water. And on my left, I have a small container. Now, capacity is the amount that an object or container can hold, the measure of the amount. So as I told you before, the measurement for this bottle of water is 500 milliliters. The measurement for this container here is 1 liter. We don't know the measurement of this one, but you all have containers at home. Any container that you have at home that can hold something has capacity. Now, when you take your medicine, sometimes your mommy uses a teaspoon. The capacity of that teaspoon would be 5 milliliters. The juice that you drink from the cartoon at school, most of the time, that is 250 milliliters. The standard unit for capacity is liters and milliliters. Now we are going to go on now and we're going to talk about volume. Here we have on the table some objects. Each one of these objects take up space. Everything that takes up space has what we call a volume. These things take up space because they have 3 dimensions. For example, if I take this cube in front of me, this cube has dimensions, 3 dimensions. It has a length, and if I use my ruler and I measure the length, it is 10 centimeters. It has a breadth, and the breadth is also 10 centimeters. It also has a height, and the height is 10 centimeters. So I'm going to write those 3 dimensions on the board. So we have 3 dimensions. We have the length, and the length is 10 centimeters. The next dimension is the breadth. The breadth is 10 centimeters. And the third dimension is the height. And the height is 10 centimeters. I want you to look around your home and see if you can find any solids that has 3 dimensions. All of these objects occupy space, so we can measure the volume. And today, we are going to learn not only how to measure the volume, but how to solve problems involving volume. Now, on the table in front of me, I have some what we call cuboids and cubes. Here we have 1 cube. I am going to use the volume of this cube, which is 1 cubic centimeter. I'm going to use this measurement to measure the volume of the cuboids and the cubes on the table. I'm going to begin first with this cube. And I'm going to take it apart. If you notice that this cube is used to build this larger cube. And if I take it apart, you'd recognize that I have 4 cubes at this layer and 4 at the top layer. And you can count with me. 1, 2, 3, 4, 5, 6, 7, 8. So we can say that this cube, which is 2 centimeters long, 2 centimeters wide, and 2 centimeters tall, has a volume of 8 cubic centimeters. 8 cubic centimeters. We can call this cube a 2 centimeter cube. I also have another cube on the table here. This cube has sides of length 3 centimeters, which means that any side that you measure, you would get 3 centimeters. And we can calculate the volume of this cube by looking at that length. So at the bottom layer, we have 9 cubes. In the middle layer, we have 9 cubes. And on the top layer, we also have 9 cubes. So that is 9 plus 9 plus 9 is equal to 27 cubic centimeters. This is a 1 centimeter cube has a volume of 1 cubic centimeter. A 2 centimeter cube has a volume of 8 cubic centimeter. And a 3 centimeter cube has a volume of 27 cubic centimeters. Now those are 3 facts that you could remember or you could learn. Now we are going to find out how we can measure the volume of solids using the formula. We're going to learn the formula for finding the volume of solids. You have a question on the board here. It says, find the volume of the cuboid. And the cuboid that we have here, these are the dimensions: 9 centimeters by 4 centimeters by 3 centimeters in height. To demonstrate how we come up with the formula for finding volume, I have a little replica on the table in front of me. Here we have a cuboid made up to represent 9 centimeters. I'm showing you the base of that cuboid. 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters by 4 centimeters in width or breadth. 1, 2, 3, 4. And we have 3 layers to represent the height. First, to find the volume, the first step is to find what we call the area of the base. You all would have done area at school, where you did length multiplied by breadth. We have 9 centimeters in cubes going along the length, and we have 4 going along the breadth. So we're going to find the area of the base. So area of base is 9 centimeters multiplied by 4 centimeters. And that is equal to 36 centimeters, square centimeters, because we are multiplying 2 dimensions. Just like the base, we have 3 layers that each has an area of 36 square centimeters. So the final step in finding the volume of this cuboid is to multiply our area, which is 36 centimeters square, by our height, which is 3 centimeters. And that will give you 3, 6 is 18, 3, 3 is 9, and 1 is 10. 108 cubic centimeters, because it's 3 dimensions. So we could say that our formula for finding the volume is 9 centimeters, which represent our length. So the formula is length multiplied by 4 centimeters, which was our breadth, or width. And then finally, we multiplied the area of our base by our height, multiplied by height. So a formula for finding volume is length multiplied by breadth multiplied by height. Or this other method that we also use, which is area of base multiplied by height. Now we are going to use that formula to solve. Oh. So using the formula to find the volume of a cuboid is just another way instead of counting. So we can demonstrate this. So we can count the base, and it would have been 9 multiplied by 4, which is 36. And then we add this 36 to that 36, and it would have been 72. And we add the final 36 to the 72, and we ended up with 108. So 36 add 36 add 36 would have been 108 cubic centimeters. Now we are going to move on to another problem where we're going to practice using the formula, which is length multiplied by breadth multiplied by height. Here we have another cuboid. Its dimensions are 5 centimeters by 2 centimeters by 3 centimeters. And we are going to use our formula to help us solve. But we're also going to check to see if our formula is working like normal counting of cubes. So we have the length multiplied by the breadth multiplied by the height. Our length is 5 centimeters. 5 centimeters multiplied by 2 centimeters multiplied by 3 centimeters. 5 2s 10, 10 3s 30. 30 cubic centimeters. On the table here we have a cuboid we can check. And if we look at the top of the cuboid, which is just as the base, we have 5 multiplied by 2, which is 10. And we have 1, 2, 3 layers. So that's 10 and 10 and 10, which is 30 cubic centimeters. So remember our formula, length multiplied by breadth multiplied by height. If you look on the table, I have another cuboid, but it's made up of cubes that doesn't look like this one. As a matter of fact, it's larger. One of these cubes is not the same size as the 1 centimeter cube. It's really the size of the 2 centimeter cubes. So this cuboid is made up of 2 centimeter cubes. So how do you find the volume of this cuboid? What you have to remember is each cube in this cuboid, this length of its sides is 2 centimeters. So let's look at the length and let's work out the length before we find the volume of this cuboid. Let's work out the volume of this cuboid. We have 1, 2, 3, 4, 5 cubes in the length of this cuboid, but each cube measures 2 centimeters. So the length is 5 multiplied by 2 centimeters, 10 centimeters. Let's look at the breadth. The breadth is 2 cubes. So the breadth is 2 multiplied by 2, 4 centimeters. The height, 1, 2, 3, 3 cubes. So these are our 3 dimensions. Now we're going to multiply our dimensions to work out the volume, which is 10 multiplied by 4 multiplied by 6. 10, 4s are 40, and 40 multiplied by 6 is 240. 240 cubic centimeters. Another way of solving that problem, remember, we found out that in a 2 centimeter cube, the volume is 8 cubic centimeters. So if we know how many cubes we have in all, it's easy for us to also find out what's the volume of that cuboid. So let's work it from that direction. At the base, we have 5 multiplied by 2, which is 10 cubes. So we have the base multiplied by the height. And we are looking for the number of cubes. So the number of cubes at the base will be 5 multiplied by 2, which is equal to 10. And we have 3 layers of cubes. So the height would be 3. So it would be 10 multiplied by 3, which is equal to 30 cubes. To find our volume, we're going to multiply our 30 cubes by the volume of 1 2 centimeter cube, which is 8 cubic centimeters. So we have 30 multiplied by 8, 240 cubic centimeters. The next thing I want to do is to show you the relationship between volume and capacity. Here I am going to demonstrate the relationship between volume and capacity. In front of me, I have this 10 centimeters cube. Remember, I measured it a little earlier, and I showed you that the length was 10, the breadth was 10, and the height was 10. And if I remove the layers, the bottom layer is 10 by 10, which is 100. And you have 10 layers like these, 1, 2, 3, 4, 5, 6, 7, 8, these two, 9 and 10. So the volume of this cube is 10 multiplied by 10 multiplied by 10, which is 1,000 cubic centimeters. I have a container that has the same dimension, 10 length, 10 width, and 10 height. I'm going to put it next to my cube so you can see the measurement. Now in my jug here, as I showed you before, I have 1 liter of water. I'm going to pour this liter of water into the cube. And it comes all the way to the top. So we see that this cube, which is 1,000 cubic centimeters, holds the same amount as 1 liter. So the relationship between a cube that measures 10 multiplied by 10 multiplied by 10 with a volume of 1,000 cubic centimeters is equal to one liter. And from there, we can break it down further and show that 1,000 cubic centimeters is equal to 1,000 milliliters, which also means that 1 cubic centimeter would be equal to 1 milliliter. I'm going to use this information to help solve this problem. Let's read the problem. So the height of the water in the container is 4 centimeters. How many more liters of water are needed to fill the container? We have a container here with a length of 20 centimeters, a width of 8 centimeters, and a height of 10 centimeters. The height of the water is 4 centimeters. We need to find out how many more liters of water would be needed to fill from this 4 centimeters to the 10 centimeter. We are going to begin first by looking at what we know. We know the dimensions and we know the height of the water. So we are going to take, in order, we're going to calculate first how much water is needed to fill the container. Okay? And that would be the volume of the container, the full volume of the container. So we multiply length multiplied by breadth multiplied by height, which is 20 multiplied by 8 multiplied by 10. 20 by 8 is 160. 160 by 10, we just add another 0. So 1,600 cubic centimeters. That's the volume of the whole container. Next, we are going to find what's the volume of the water that is presently in the container, which is 20, using the same formula, multiplied by 8, multiplied by 4. 20 multiplied by 8 is 160. 160 multiplied by 4 is 0, 4, 640 cubic centimeters. The question, however, asks us how many more liters of water. Liters of water. Here we have volume, which is cubic centimeters, and they want liters, they want capacity. If we look across here, remember that 1 cubic centimeter is equal to 1 milliliter. So, the amount of water that is presently in the tank is 640 cubic centimeters. So I'm going to write down that in milliliters. So 640 cubic centimeters will be equal to 640 milliliters. That's the amount of water in the tank, in the container presently. This is the amount of water that is needed to fill the whole container. So I'm going to also convert this to liters. 100 milliliters take away 640 milliliters will be equal to 960 milliliters. So I'm going to change the 960 milliliters to liters. So I'm going to divide 960 divided by 1,000. So 10 is a factor that can be divided into 960, and 10 is a factor that could be divided into 1,000. 10 into 960 is 96, and 10 into 1,000 is 100. So we have here 9,600 liter. So the amount of water that is needed to completely fill the container is 9,600 liter. The next problem we are going to look at is how to find one dimension when you know the volume and two dimensions. So the problem says a solid cuboid has a square base of side 6 centimeters. It has a volume of 540 cubic centimeters. What is its height? So what do we know? We know that it has a square base. So the area of the base is 6 centimeters multiplied by 6 centimeters, which is equal to 36 square centimeters. They also gave us the volume. So in order to find the volume, just as we recognized before that the volume is really layers of the base to the top. So my area of my base was multiplied by my height in order to give me my volume. So I'm going to divide my volume by the area of my base. So I'm going to divide 540 by 36. 540 divided by 36. 9 is a factor of 540 and 36. 36 divided by 9 is 4. 540 divided by 9 is 60. 4 is a factor of 4 as well as a factor of 60. So 4 divided by 4 is 1, and 60 divided by 4 is 15. So our height is 15 centimeters. So in order to find the height of a cuboid, when you have the area of the base, you just divide the volume by the area. This problem says, your teacher stores 18 cubes in a rectangular box. The box is 10 centimeters long, 4 centimeters wide, and 5 centimeters tall. Each cube has a side of length 2 centimeters. How much extra space is in the box? So we know this is the dimension of the rectangular box. We also know that there are 18 cubes in the box, and we also know that each cube has a side of length 2 centimeters. The question is, how much extra space is in the box? So it means that the box is not filled. So we must find out the volume of your box, which is one of the things that we're going to have to calculate. And we're also going to have to calculate the volume of the cubes in the box. So we'll begin first by finding the volume of the box. So volume is length 10 multiplied by breadth 4 multiplied by height 5. 10 multiplied by 4 is 40, multiplied by 5 is 200 cubic centimeters. That's the volume of our box. Now let's find the volume of the cube. Now we can find the volume of the cubes by finding first the volume of one cube. These are not 1 centimeters cube, they are 2 centimeters cube. We found out before that the volume of a 2 centimeter cube is 8 centimeters, which is 2 multiplied by 2 multiplied by 2, which is 8 cubic centimeters. That's for one of the 2 centimeter cubes. The box has 18 of them. So we're going to multiply our volume by 18. 18 multiplied by 8 144 cubic centimeters. So that's the volume of the cubes in the box. And this is the volume of the box. How do we find the extra space? By simply subtracting the volume of the cube from the volume of the box. 200 take away 144, 6, 5. 56 cubic centimeters. That's the volume of the extra space. So, what have we learned today? We have learned that the volume of a container is the measurement of the space that it occupies. And we use cubic centimeters or cubic meters to measure volume. We also found out that 1 liter is equal to 1,000 cubic centimeters. That's the relationship between volume and capacity. We have also found out that our formula for finding volume is length multiplied by breadth multiplied by height, or area of the base multiplied by the height. The final thing that we found out was that we can find one of the missing dimensions, such as the height, if we divide the area of our base into our volume. Thank you for staying with us, and we hope that you will continue to view these lessons whenever they are scheduled.